Hello everyone and welcome to this video, and today's topic is light attenuation. And just quickly, what is the light attenuation? Well, basically it says physical attenuation is gradual loss of flux intensity through a medium, etc, etc. But basically, for example, water and air attenuate both light and sound. So we're actually interested in this light, and we can model that attenuation. It's basically a fall-off of light, so maybe I can explain it here. So for now, I'll just explain it quickly like this. Let's say that we have some, and this is our distance. Let's say that this axis represents distance, and this y will represent light over distance. So let's say that light is at distance 0, some 5 units strong, and then as it increases in the distance, light kind of falls off, right? And somewhere over here it might be 3 units at a distance, let's say 4, right? So that's basically it. It's just we model this fall off of light over distance, and we can do that really simple, and usually it's modeled as so here I'm just saying our x is going to well, our y value is going to be whatever the x is. So for example, if I place it like this, we have this, but as it's falling off, actually the value of attenuation goes over x, and it's usually squared, right? So we have this distance squared, but we will also have some terms, and you can see here that it falls off. It's just that here it goes into infinity, and then we have some variables with which we can control this. We have this idea of a quadratic term, so quadratic terms goes here, and then we have also linear term. It's usually modeled like this, just so that basically this just control the function so that you can play more with it. So we can say linear times x, or the distance, then plus quadratic times basically x squared, distance square, and then we can also have constant term, and then the constant is just plus, right? So we have this kind of nice function here that falls off over a distance, like I mentioned. So distance goes here, and then this value falls off. Maybe I should just clean this quickly. But basically you can see here, as distance increases, the light basically decreases, and then it falls nicely. And then with these variables you can control well, basically the how it falls off, right? So you can increase or decrease basically constant term. Same is for linear, and then the same is for quadratic. But usually these are nice values. For example, this one is nice. Okay, so we just have to model that, and for that we can start with the shader, because it's real simple. So let's just start here, and then we're also going to get rid of these rotations as well. But first let's just go to our, not material, but actually shader. Oh, I am in shader, my bad. All right, so for attenuation we just have to extend the point light. So we can say here constant. Oh wow, that's really handy. So we can just skip these names. It's totally fine. Maybe actually, so just as we know what it refers to, so attenuation, and then quadratic. Maybe this is a bit better, so that we know that it's referencing attenuation of the light. And then here somewhere, because it's on point lights, so we can just say yeah, how do we model actually attenuation? How do we get this distance? Well, the distance is, as here it suggests, it's just position of a light minus fragment position. So what's the distance, right? We have this light here, and then we have, in our case, cube, and then it has maybe some fragment here. It's not important. This can be also fragment, and then we just need to find this distance, and that's the distance. So we get it by taking light and subtracting the fragment position, and then we just have to take length of that vector. So that can represent distance, and then we also have attenuation. So here I'm just going to move this real quick, and then I'm just going to break it into 3 lines, because I think it's a bit easier to see. So like I mentioned, attenuation. So we're going to do 1 over right now, but just to describe it here, so we have constant part, which is this part. Then we have plus distance, right? So here this distance times linear part, so linear, and times, this is times actually, and then plus as well, attenuation times quadratic part. So basically we have quadratic term times, well, basically distance squared, or distance times distance. And then here we just have to, right, because it's an inverse, we just have to do 1 over. So I'm just going to do that. Attenuation is 1 over attenuation, and then here this should have been here instead, and then we just multiply that value. Right now it doesn't work because we still have to change a couple of things. So let's get to it. So I think that only change that we need to do is in our point light. Here we had byte size 3 times 8. It actually has to be 3 times 12. If you remember from the last time, this 3 over here stands because we have 3 point lights. 12 is the buffer size, but we now need to extend it. Before we had 8, right? We were packing what we were packing. We were packing these colors and then intensity, and then those were 4 first byte, and then the second 4 byte of those 8 was this. So we have to extend it here. Let's do that. So here, actually, I just need to model it here. Then constant or const, and 1 is fine. Linear is fine, quadratic is fine as well. We can just move this to 0.1. That's fine. Those are good suggestions, actually. Those are nice values. And then here, we're just going to say this lights I constant, attenuation linear, and then the last 2 bytes are not important. So they can remain 0 and 0, and then paste just linear, quadratic, and that's it. So we had to extend here, and we have to extend here as well. So I think, well, that already works. So I think we can already play with the values here. So which one is green light? We can focus on this one because it's easier to see. Let's go to our main. Which one is green one? Let's see colors. No, this one, middle one is green. So we can just play with lights, not the position, but actually attenuation constant, and let's just say 0.2. Okay, you can see here, right? This part is constant part, and then it falls off gradually over distance, right? As it goes to this fragment here, the value of the light falls off. So you can play further with it. You can say linear 0.1, that's not that big, but let's say 0.01, and you can already see light getting bigger. So the lower values here will result in bigger light, and then if we say this, it increased it a bit. Okay, well, you can play with it. I just wanted to model that and explain that. So that was really easy, nothing spectacular. So you just remember, if you need something model, you can use this tool to basically model a function, and then it becomes clear what it does. All right, then, so further is just some small thing that I wanted to do. Okay, weird. And that's, I would like to have input so that we have some gameplay, because we're going to need gameplay. Well, basically we haven't done anything with gameplay, so I want to do that actually. And for that we're just going to create some input, and I'm just going to call this input manager. And in our input manager we can export it. We can create private keys, and that's fine. It can be a map of string and then boolean. So we're going to have a constructor on key down. We're going to receive key, and then we can set, right, the key of this dictionary to true. And then similar, we're just going to have for key up, if our key up, then we set it to false. And then I just need one small method that's going to check for the values. Is key down? Exactly. We can check for the key if it's in dictionary, or if it's not, we can add false. Exactly. So if key is down, we're just going to return true for the key if it was ever pressed. If we receive key up, we just unset this, or basically set it to false. Okay, cool. So further, we're just going to need to go to our pedal, and then we just have to pass that input manager, and I'm going to do it as a second parameter. And I can just say here private, because I don't need to use the setters then. And that's it. Okay, format it. And then in update, we can get rid of this angle. We're not going to use that anymore. So I'm just going to get rid of this bit of cleanup. We don't have rotation anymore. We can just here do translate time scale and get rid of rotations. And then here, what we can do is just handle those inputs. Basically, what I need is, what do I need? We're going to need private. So we're going to need direction. No, speed. Yes, speed. We need a kind of speed which we're going to use for our pedals, and then we can say here let direction y is equals 0. And what else do I need? I need to know which player. So basically we're going to have player 1 and player 2 for the left and the right pedal. So it's going to be 2-player game, and then you can play it with someone. That's not that important really, but just by default we're going to say player 1 to true, and then if player 1, I'm going to use if input manager is key down, right? If W is pressed, then direction is going to be 1, and if S is pressed, then we want to go down, so direction is -1. And then else, if player 2, then we're going to use arrow keys, as you can see. And then we can just say this position plus equals direction y times speed, and that's almost it. So I just want to test it now, and that's probably not going to work yet because we need to pass input manager here. So I can just create it, const input manager. We can create input manager and then pass it to pedals. And with that said, if I try to play our game, if I press W, there it goes. There it goes, and we're almost done. We're almost done. One more thing that I want to do is just to clamp that. And let's do that quickly. So we can do it here. If this position y is greater, I think that 5 is probably a good value. Then we just set it to 5. Else if it's less than 5, we set it to -5. So now it's clamped. So I cannot go above this or this value, and that's probably good. Okay, that's basically it for this video. So we just quickly covered attenuation, which is really simple. Like I mentioned, it's just a fall of light as is defined here. Basically, we just kind of model light as it goes through the air or whichever medium it is. It might be water. We just kind of model some fall off, which basically looked like this, right? We have distance here, and then here lights fall off as it goes over distance. And that's basically it. We just had some variables which allows us to control that fall off, and then that's it. And the rest is just some gameplay because we needed to edit. And the next time we're going to do is specular light, and then we have to do shadows, I think, and maybe split screen as well. And then we're almost done with this video. So hope you enjoyed this video. If you enjoyed it, please like, subscribe, maybe leave a comment, and until next time.